Black holes. What exactly are black holes? Well, black holes are amazing cosmic vacuums that can do incredible things. Let's learn about that topic today. In order to understand black holes, we must focus on the parts of black holes. The innermost part of a black hole is the singularity, where space-time curvature becomes infinite. Unlike literally everything you, I, or anyone that has ever lived has seen, well, you can't really see the singularity. The reason you can't see the singularity is because it has no shape, size, or volume. Even though this is the case, the singularity holds all of the mass of a black hole. This makes the singularity infinitely dense. This is of course only recent calculations, and we may never truly know the real singularity. The next part of the black hole is the photon sphere. The photon sphere is the part of the black hole in which light can still escape, while light that crosses the photon sphere on an inbound trajectory will be captured by the black hole. Hence, any light that reaches an outside observer from the photon sphere must have been emitted by objects between the photon sphere and the event horizon. The next and most well-known part is the event horizon. To a distant observer, clocks near a black hole appear to tick more slowly than those further away from the black hole. Due to this effect, known as gravitational time dilation, an object falling into a black hole appears to slow as it approaches the event horizon. This makes it so an infinite amount of time will pass before the person you will see. Let me reword this. An infinite amount of time will pass before you can see that person actually enter the black hole. At the same time, all processes on this object slow down from the viewpoint of a fixed outside observer, causing any light emitted by the object to appear redder and dimmer, an effect known as gravitational redshift. Eventually, the falling object becomes so dim that it can no longer be seen. The final and easiest part to escape from is the ergosphere. The ergosphere of a black hole is a volume whose inner boundary is the black hole's event horizon and outer boundary of a oblate spheroid, which coincides with the event horizon at the poles but noticeably wider around the equator. The outer boundary is sometimes called the ergo surface. Now that we know the very basics of a black hole, we can move on to observational evidence. By their very nature, black holes do not emit any electromagnetic radiation other than the hypothetical Hawking radiation. So astrophysicists searching for black holes must generally rely on indirect observations. For example, a black hole's existence can sometimes be inferred by observing its gravitational interactions with its surroundings. That should about sum it up for today. We will return in the next few days. Remember to keep learning.